leading to or generating great value economically.
The second example is speed optimization for ship owners. Through operation data analysis, we can provide ship owners with analysis of the routes, its meteorological conditions, as well as along the route and journey, all the data that has been collected, as well as the data about the loadings. So based on the data, model, and expert experiences, so we will have a performance model to guide the ship owners on how to adjust the rotation speed of the main engine and decide the speed of the ship for maximum energy efficiency. Ship owners, especially in fixed route, will have an optimal solution. The third case, we monitor the normal operation data of a ship, including oil and fuel consumption, speed, and weathers, so we can monitor the following of the ships. And we will be able to produce a window opportunity to the ship owners. So based on their operation plans, they can arrange the following removal procedures in a more flexible way. This case study provides digital and precise solutions. The benefits and profits generated would be huge. Without these digital tools, the ship owners can only rely on their own experience or their own eyes to monitor the following. And they will more rely on the oil consumption from the parameters of the motors or engines. But with digital rules, we can sustainably and accurately monitor the following, and ship owners can accurately manage their energy efficiency. Equipment and the main motor or engine are the targets of our monitoring and analysis. There is another example. Another ship owner, a lot of the ships are cruising at low speed, but when the speed reaches a certain level, the rotation speed of the main engine would be very low and the auxiliary blower will start to work. For this ship in case, the rotation speed is varying because with low speed cruising, they need to let the speed to go up for quite a period of time in order to protect the main engine. But such kind of operation model will also lead to the result that the energy consumption would be increased. So by using the real data, we recommend a rotating speed of the main engine to ship owners will reduce the time of operation of the auxiliary blower. And it can have a benefit of 6.4% as compared to the ship owners' previous operation models of both low and high speed. So while the ship owners operate the ships, they can use the data to have better support to operations and have better analytics. And they can improve the efficiency and the level of management of their operations and reduce energy consumption. Another example is about the main engine condition monitoring. We detected a problem with the exhaust valve, but through our digital analysis, we would be able to predict 1 week in advance the possible leakage and erosions of the exhaust valve. So we talked a lot about energy efficiency and the condition monitoring of the main engine. So these operation data in the real world can help us to do a lot of optimization. Here is another example about real-time monitoring of the main engine condition, we found that the rotation speed of the main engine is gradually decreasing. And we looked at the sea conditions where the ship is located and the condition of the operation of the main engines. We also look at the SCAF air press limit to give our possible suggestions to the causes of these problems. We can effectively support the crew members to maintain a healthy condition of the main engine. When we monitor all these data and when we do data analytics, very often we will detect similar problems. If these data is in the hands of experienced captains and crew members, they would also be able to detect possible causes. But by using data analytics, we can better help those on board to identify possible faults. So it is because of the dirt inside the equipment that the SCAF air pressure is very low, causing the problems in the condition of the main engine. So we identify these problems and give optimization advice to those on board. This is an example of analyzing energy consumption data. This is a typical case. The ship owners installed quite a lot of scrubbers to meet environmental protection regulations. And when a scrubber starts to work, we need 2 generators to work at the same time. And as a result, the per unit oil or fuel consumption would be high as 243. So it is an increase by 50%, and the load of the operation of the generators is lower than 50%. So the fuel consumption is high and the operation load is very high, and it is detrimental to the service life of the generators. So we talked with the ship owners and equipment manufacturers. We optimized the operation model of scrubbers in order to improve the overall fuel consumption. So that these two can be aligned in a more synchronized manner. It is not to say the main engine is running at 100% capacity all the time, so the scrubber systems can lock up the rotating speed of the main engine in order to reduce energy consumption. If the main engine is not at 100% capacity, then the running of the scrubbers it does not need to run in its full capacity either. As a result, in 80% of the time, we can use only 1 generator to support scrubbers, because in 80% of the time, it is not 100% capacity full operation. So according to our estimation, we can save about 400 tons of fuel on an annual basis. So this is a very good case to show that we can have very good energy conservation results through data analysis. Operation data analysis would enable us to give suggestions to operation and the shipping. These are just some of the examples, but generally speaking, smart ship, digitalization, and autonomous ships will promote the digitalization and the smart development of the shipping industry as a whole. Because all the activities will have ships at the center. Only with smart ships will be able to realize smart shipping and autonomous shipping in the future. That's all for my presentation today. I welcome your insights and feedback. Thank you. Thank you, Mr. Li Xin, for your presentation. And you talked about some projects of intelligent ship of China, and all these examples are really inspirational and interesting for us to understand better the development of intelligent ship. And intelligent ship is closely related to intelligent shipping, and we also need intelligent ports or smart infrastructures. So now I would like to invite the manager for business line Marine and Ports and China head of Global Products Group Electric Solutions from ABB Marine and Ports, Mr. Ottner.
Today I will talk about the voyage towards emission-free and autonomous shipping by focusing on the power solutions which are suitable for targeting unmanned shipping and also unmanned ports. The topic I will present today are basically these three topics. I will start to go through some of the megatrends and the voyage ahead as we see it here. And then I will have a section on electric solutions and mainly focusing on fault-tolerant power systems which are suitable and designed for future autonomous shipping or even unmanned shipping. I will round off by going through this digital and connected and what that means for intelligent shipping before rounding off the presentation. There are undoubtedly quite strong megatrends in the world, in the industry, which also transforming the shipping and the whole logistics around shipping. I will mainly focus in this presentation on the left side, the digitalization and automation systems, and on the right side on carbon-free operations and the environmental impact from shipping and transportation. I will first start with the digital journey. As we see it, the journey towards emission-free and autonomous and even unmanned vessels is a stepwise development. We don't see this as a kind of a short-time revolution, but we will see incremental steps going forward where each increment has a value for industry. Each increment, each step forward must have a payback and a rationale to be launched into the market. We come from a past where we have operated the fleet like isolated vessels, operating where the captain was the king and reporting back to the fleet management now and then, maybe even not even every week, towards where we are today on the collaborative operations, where we today can connect the vessels together. We can connect the vessel via satellite communication to shore operations and to fleet management offices. And we are seeing now also development and piloting and testing of doing remote operations of vessels and cranes and ports and towards fully autonomous operations. The way forward towards autonomous and unmanned vessels is probably long and windy, and we see that the solutions that are coming to the applications now and to taken into use are steps on that way towards autonomous. If we look at the lower side of the diagram here on the powertrain, we have also seen during the last decades a tremendous development in the propulsion systems, coming from a conventional mechanical design towards electrical propulsion, and now also coming in energy storage systems and batteries. And we also see piloting and test installations of clean, environmental friendly, carbon-free fuels like hydrogen using fuel cells, or short charging to reach the IMO targets of CO2 emissions for 2030 and 2050. The way forward for towards autonomous operations and intelligent shipping, we need to take a look at what is today on board a vessel. And basically, it is not only enough to enable this autonomous navigation, but all the other ship systems also need to be prepared for autonomy. So simply speaking, we can say that, well, we don't only need to have a digital captain, but we also need to have digital first officer, a chief, and we need to have a backbone of propulsion and thruster systems on the vessel to facilitate autonomy. So, starting with the electrical first. Here is on the right side a conventional electric propulsion system where the electricity is generated by the generator sets, run typically by a combustion engine, could be diesel, it could be gas, and then electricity is distributed around on the ship and also providing the electrical power to maneuver and to propel the vessels. What we have also seen in the latest years is the gradual introduction of battery and energy storage into the electrical systems, and what I also mentioned previously, we see also an introduction of the fuel cells, which are now being piloted in several of these pilot projects that are started around the world. This kind of system has proven to have a good reliability and a good fuel efficiency in the past. I will take this particular diagram here and break it down into a reliability and availability diagram, looking like this, where we can see on the left side we have the energy sources or the power sources, which could be combustion engines. We have the gray part in the middle, which is the electrical distribution system, and at the end here we have the propellers, which is moving the ships ahead and doing the maneuvering. One of the, I would say, characteristics of this kind of system is that the redundancy is built up on a system level. So in this case, if there is a single point of failure, for example, in one of the distribution systems, we will lose 50% of the capacity of the vessel. And that might be fully acceptable. And if there are crew on board the vessel, the crew will then go to the engine room or to the electrical room and find out what is wrong, replace the faulty part or start up the faulty system again and come back to full operations again. For an autonomous vessel and for a future intelligent vessel, that might not be the case, that there are crew on board who can do it. So we will have to take a look into how this configuration could look like in order to ensure that the availability and reliability of the vessel is at the same level or better than for a conventional operation. One of the reasons why this has been the traditional way of doing it is that it is cost efficient, cost effective, but maybe even more that it is fuel effective. If you have fewer larger prime movers, they have typically a higher efficiency and lower fuel consumptions than a number of smaller prime movers. If you look into fuel cells and batteries as of today, as we see it today, they are a little bit different from a combustion engine. So fuel cells and batteries, they have a pretty constant energy efficiency or power efficiency independent of the size of the unit itself. So with fuel cells and batteries, we do not necessarily need to to have the same design principles as in the past by choosing large installations, we could use multiple smaller installations and not sacrifice significantly or unsignificantly sacrifice efficiency and fuel consumption. So with new energy sources and batteries, there is a possibility to look for other configurations which are more suitable for autonomy and for intelligent vessels. The traditional system that we looked at that is what we call a radial system. So in this case here, we see three different, I would say, sections of the power plant connected in the radial solution. But we can also imagine and see that there are other ways to connecting these sections of the power system. We can do it like here in a 5-split star system, or in here in a 4-split ring system, or here even in a 5-split matrix system, so we can interconnect the subsystems and the sections of the power plant in multiple manners. So the matrix system is definitely the highest flexible configuration, where we have a lot of possibility to reconfigure the system in case there is a single failure in it. And this reconfiguration can be done automatically, or it can be done remotely by a remote chief engineer or by a digital chief engineer on board the vessel. And since I said that these new energy sources are not suffering too much of energy losses or power losses by the size, we can also think about combining these different systems in any combinations. We can combine these matrix systems, which gives a very high availability through reconfigurability of the vessel, with high redundancy power sources, this island of power sources, where each power source has a smaller contribution to the overall power system, and hence the consequence of a failure is less. Where we see that we probably will not find good solutions for high and redundancy solution is on the propulsors. They still will have this benefit of having efficiency of larger units, so their solution probably will be to have low N redundancy, but built-in solutions which have intrinsically or by nature high reliability and few failure modes. I do not foresee that this particular solution that you see here will be realized in the near future, but this is more to illustrate the idea of introducing this new way of thinking to make sure that the electrical propulsion system or the propulsion system as such can be operated remotely or can be operated in an autonomous manner. And going more into this digital and connected, what is the digital captain, the digital first officer and the chief? And here there are a lot of documentation and standards and regulations started to come now. I have used this CCS iShip notation or iShip standard as a platform or a starting point to explain what we are talking about. So as you know, the CCS iShip notation has these 6 different notations from cargo, energy, machinery, hull, navigations, and then the platform itself. And if you take this iShip regulation and map it into the technical solutions, we could form this pyramid in overall IT structure and the software structure on board the vessel. I will guide you through each of these one. So I will start here with the devices and sensors. The prerequisite for achieving intelligent vessel notations and autonomous operations is to have intelligent devices and intelligent sensors to measure how the vessel performs and how it is navigating and what is the conditions on board the vessel. And already today there are a lot of equipment, and most of the equipment today, I would say, put on the vessel do have some kind of an intelligence built in. Intelligence for control and for monitoring and for protection. And this slide here only shows a few of our product portfolio where this kind of built-in intelligence and built-in sensors can be applied to monitor the vessel installations. If we then take the next level here, the automation system, and the automation system is the connecting device between the intelligent devices and sensors to automatic plant control. So automation is used to control the processes and the plant on board the vessel. When it is a system like shown here, we call it an integrated automation systems, where all essential and cargo functionalities of the vessel has been integrated in one common automation system on one common platform and communication network. Going to the operational level, on top of the automation systems and the control systems, we also see now a very fast introduction of advisory control systems or advisory system and automatic vessel control, automatic docking, maneuvering. We have a remote situation awareness system where the sensor or the vessels can be used to analyze and present to the crew and to the fleet management office what is the conditions surrounding the vessels, especially when operating in the collaborative operations in the offshore, for example, or navigating near harbors in dense areas. And we have also a support system that can give either fully automatic control of the vessel or give advisory how to operate the vessel for maximizing the comfort of the passengers and the crew or safety of the cargo. And finally, at the end, the remote control operations, where all these systems can be connected to a remote control center to be monitored or even taken control of by remote resources. And remote access and remote control, that will require also a communication system. So that means that we need to have a communication. In this case, we have drawn this cloud, and that is today's technology to collect information and to share data among the different users of the cloud. And that means that the fleet and operation centers and suppliers and ports should then have this connectivity towards this cloud system and using satellite communication or other way of communicating with the cloud and to the connected collaborative units. So this is the numbers on the lower corner here that illustrates what we in ABB have today, our cloud connection. We have about 1,200 vessels which can be connected either continuously or on demand to this cloud. And we have 3 global collaborative and 4 regional and specialized operation centers to serve this fleet of 1,200 vessels. The purpose of collaborative operations is today just in the very, very beginning. We see a rapid development in applications and in apps, if we want to call it like that, to do this analysis and support and monitoring system, monitoring of the installations, and not only the vessel installation in itself, but also the whole fleet operation. These collaborative operation centers, they are staffed 24/7. They can be globally connected. We have optimizing or system to optimize the operations and give advices, remote advices, and also do condition monitoring and give maintenance advices to the fleet or to the vessel itself. With this condition monitoring, there is also much better possibility to plan maintenance and to do extended lifetime of not only the vessel itself, but equipment on board the vessels also, if those are operated in a most optimal manner. So to round it off, we believe that electric, digital, and connected is an essential part of the voyage towards emission-free and autonomous shipping and ports. The voyage has started, it is ongoing, and it is ongoing rapidly in certain areas and coming very fast also in new areas. And I think what we see today is just the beginning of the future, and we will all be affected by these changes, and I hope that we will have a good collaboration in the marine industry to develop us into this new reality. Thank you. Hello everyone, good afternoon or good morning. Today I will talk about the voyage towards emission.
I'm sorry, I was on mute just now. We have got one last presentation to go, but also a very important one, because we talked so much about smart shipping, smart ship, but at the end of the day, we must look at what are the attitudes of the ship owners towards the digitalization. So now I'd like to give the floor to Mr. Chen Huaihai, Product Director of Research and Innovation Center of COSCO Shipping Technology Corporate Limited. Digitalization can revolutionize the development of companies, but how do we build data capabilities, creative values, and empower our businesses? These are all the things that companies need to consider, and we need to enable us to push forward the advance of our business and technologies. So what about digital companies as compared to conventional companies? They can innovate better, faster, but they will adopt a customer-oriented approach, and the digital capabilities and the smart capabilities can be embedded in a broader ecosystem, and it will also bring the company with more revenue sources. As a company become a native company of digitalization or in its digitalization transformation, what are the technologies and the development trends to drive us to become a digital company? In the past so many years, especially the recent 2 to 3 years, we can see so many aspects of technology advances and evolutions. All of these have provided digital companies with possible technology support. First of all, artificial intelligence, AI. Limited by algorithm and computing power, the AI is more applied in specific scenarios, but with upgrading of the algorithm and computing power, AI's capabilities can be applied not only in specific scenarios, but also on the edge. The same is true for data. Data will only structured data in specific scenarios. The storage of the data collection and analytics are limited. I cannot process real-time large volumes of data, but with upgrading of my capabilities, including data collection, processing, distributed calculation, computing, etc., we have the power to process all these data. And with these capabilities in hand, there will be some new chemistry created to upgrade the operation efficiency of the companies and the enhancement of the businesses. We are no longer limited to conventional graphics interface as well as mouse or the screen. We have got more ways to interact with our customers. Based on these requirements, we also need flexible, diversified architecture to support the scalabilities of capabilities. So the mid platform is a very good starting point. With these technology evolutions, digital companies have got very good driving forces for further development. As a result, at the current stage, in the current scenarios, we would be able to ignore some of the technology barriers, but rather focus on the scenarios of businesses for better innovations as well as business benefits. So these are some of the trends that we have seen, as well as the scenarios. In the scenario of shipping, the new technologies needs to be combined with traditional shipping businesses, and how conventional businesses can rely on new technologies to create new models, possibilities, and to unleash businesses that were impossible in the past for new opportunities. A very easy example is that with mobile internet and the smart wearable devices, we can collect data in a real time, the health conditions of the crews, for example, and after collecting this data, I can have better safety management and division of labor for the crew members to make them smarter and more rational. And with mobile internet and other technologies, the service to the crew members and knowledge sharing of the crew members, the training and talent development of crew members will have new ways. It is no longer confined to conventional models and methods. With AI and graphic recognition, the conventional ways of safety management can be enhanced. In the driving cabins, if I'm going through dangerous waters or when I need navigation guidance, then the captain must be on the site. So we can use these new technologies to check if the captains appear at a designated spot at a designated time and whether they operate and perform in accordance with the regulations and standards. It will greatly enhance the safety management of the ships. Another example that you can easily relate to is that COVID-19 is spreading across the world. During the pandemic, and we, especially in Chinese mainland, we use this health QR code. The generation of the health QR code can help the reopening of the companies and economies. This process of reopening would be more smooth and more efficient with the health QR code. But where do these codes come from? Maybe at the very first beginning, they only collect data of the trajectories of the peoples from point A to point B. But if we overlap it with places, times, as well as high-risk regions of the pandemic, etc., and personal information, all these combined would give us a QR health code. And I will be able to understand whether you have been to certain areas over the past few days, whether you're exposed to high-risk people, and you will have a code in a red, green, or yellow color. With this code, you can have access to certain venues, and you can avoid manual labor of verifications. If we use human powers to verify the journeys and the trajectories, it would be very time-consuming, and we cannot ensure the authenticity of the data. Another important data is the position of the ships, and some of them is collected by AI, some of them is collected using other methods, the trajectories and routes of the ships. But if we only look at the data of the trajectories without overlapping other dimensions, for example, business operation, information, ship operation working conditions, the ports, waterways, for example, if we cannot overlap these data's only geographic location information does not have much value. When we integrate these values, we will be able to understand the dynamics, behaviors of the ships as well as the operation efficiencies for identification and analysis, and I will have got a full life cycle data from the shipping, and these will support the digital operation, the ports, the products, and shipping related data and information which I can analyze. So through these analysis and through smart algorithms, I would be able to help the companies in refined management and digital innovation. So this is also why we try to mine into the industry data and the values we try to create. This is the original purpose why we are engaged in this kind of businesses. And this is our architecture for data mining services or data mining platforms. First of all, as you can see, the cloud base, we don't need to talk too much about it. We have a hybrid cloud architecture to support our strong platforms with computing power. We also have got a basic data layer, include the position of the ship as well as other basic informations of the ships, the berthing, as well as the ports, the weathers, etc. And we will also include the management ships platforms and the crew member management platforms and other platforms of industry business operations. All these data through cleansing, storage, and processing will help us to support our full life cycle data display. There will be different dimensions. For example, the profile of the ship during the voyage, what about anchoring and the berthing, the loading and unloading of the cargoes, and the repair of the ships, whether the ships have been to dangerous water areas or designated areas. So all these full life cycle data of the ships can be displayed, and I can use them to support the big data analysis and processing layer. With these data a full life cycle as the foundation, I can have inquiries at real time. I can run machine learning. I can use big screen as well as a data access point or data services to share my capabilities externally, and these can be used in our business systems as well as for innovation projects or some new innovative products and scenarios. So through these data services, we would be able to achieve the effects that were unimaginable in the past. In this process, we will provide a lot of ways to explore. For example, we can explore in the field of ships. It is not just about the record history. We will not just look at the numbers of the ships to search, but I can look at the types, the natures, the characteristics of the ships, the ocean zones of the ships, and what kind of ships am I searching, and what are the ships that are now in some specific areas, etc. So with all these different ways of exploring and searching, I will have got very flexible service delivery capabilities. Our business systems and our customers, when using our data service, will have more flexibilities and accuracy and precisions. They will use these services in their own business scenarios as well. For example, the smart scheduling and dispatching of crew members. How do I find the suitable people? So through these kind of searches, it will be easy for me. I can search those who have sailed on the North Pole journey over the past 2 years, and I want a person within a certain age range. I need to look at different business systems for such kind of inquiry and search. I might need to go through several steps. But with this integration at the Med platform, I would be able to do this very easily. On our platform, we integrated about 200 data services to support these innovative scenarios and businesses. And it also includes different topics. For example, risk monitoring of the ships. And based on our initial explorations, we also looked at our platforms, whether they can be integrated with our businesses, the ship's risks, whether they can be some early warnings of the operation of the ships if the ship is cruising at low speed or is stopped for a long period of time. I can also look at the competitors for this kind of ships. What are the operation conditions of my competitors, and what are the port status that they will appear what are the ports for loading and unloading of cargoes. And we can also look at the ports or logistic links of priorities to monitor the conditions. We can look at the Panama canals. What is the traffic of the ships? How many ships are waiting there? And what are the ships are now passing the canal right now? We would be also to give some commodities indexes so the business companies can make use of these platforms to guide the distribution and operation of their businesses. We also have got the freight indicators and the other relevant indicators on this platform. We will be able to track these indicators. I can follow these indicators once there are changes or once they reach the threshold value that I set. I can push this information to them in the format that they require. With these data capabilities, originally, maybe my predictions and understanding of the market of the ports can have better ways or methods or better, more flexible tools. So this slide shows our analysis of the competitors.
And we have done a competition analysis. Who are our competitors? What are the competition scenario? And all this can be developed according to the requirements of our clients. Of course, we can make more specific, more specialized design with regard to this page. In that way, a lot of clients will be willing to use this product. Well, in the past, ship owners can only look at themselves. They don't know what is happening at the competition side. But with this tool, they can have the latest information about their competition, and their strategies will be much more effective than previously. So with data services, we can help our clients to make better decisions, to make better predictions, and with these predictions, with these insights, they can solve issues before the issues become too serious. In the next slide, I'll do a sum up. So in the interest of time, I have to cut it short, and I hope in the future I have more opportunities to exchange ideas with you. And on this platform, we can achieve the following 3 results. First, we can better optimize the existing operation. We can make full use of the data we've collected, not only the data from the company, but also the data from the outside. For example, external data and pre-processed data. With analytics of this data, we can make science-based assessment, giving our support to navigation dispatch, so that we can improve the management level of shipping companies. Second, we can enhance our capability to manage risks. The platform offers more than 20 warnings, all kinds of warnings and alarms, and these warnings and alarms can be pushed to our clients, even on WeChat. For example, in 24 hours or in 48 hours, the vessel is going into a risky zone, and then the person in charge will be able to get that pre-warning. In that way, he or she can better manage the risks, the potential risks. And third, with this platform, we can enhance our capability of collecting intelligence of our competitors. With the data we've collected, together with data in the public domain, we can have better understanding of our competitors so that we can carry out our strategies, cooperation or competition with our competitors so that we can make better informed decisions in terms of investment. And I hope with this platform, clients can have access to our services through desks or other means. And if the market is interested, we also want to bring this platform to the market. Well, in the interest of the time, I have to stop here. I want to thank the organizer again for giving me this opportunity. And I want to thank you for listening to me for the past 20 minutes. And I hope in the future we'll keep connected so that I can have more opportunities to share the latest information from my company with you. Thank you. Thank you very much, Mr. Zheng Huanhai, for your presentation. Ladies and gentlemen, now that's the end of our afternoon's session on digitalization. I want to thank all the speakers for their insights, information, and comments on digitalization in the marine industry, and I hope these ideas and insights are inspiring for you. We have a few minutes break, and then we're going to have a panel discussion. At the panel discussion, we're going to have with us Dr. Martin Stockford and other panelists so that we will be able to follow the latest trends in the industry. So I'll see you in about 9 minutes.